We are back. Okay, this is the second one I did. I did the zinc first. The second one I did was the lead. You can see the piece of lead at the bottom there. We've got the water up here. And I try to be very, very accurate with these graduated cylinders here. I was being accurate to the 100th place. That's 91, 2, 3, 4. And I got to get this at the right angle called parallax. I put it 94.9 for my volume. The meniscus was just under that 5 point. So I was being accurate. So you can see that when I wrote that down, here for the lead, I put 94.9. The original volume before was 88.7. So we're subtracting these two, and don't worry about it. You might say, well, you take 88.7 and subtract 94.9, you're going to get a negative. But you're getting the difference. It's only about the difference in the two volumes. So don't worry about a negative. Just subtract those two numbers. And you come out with 6.2 milliliters. So over here, for the volume of water displaced and the volume of the lead, we put 6.2 milliliters or 6.2 cubic centimeters. Very important thing in chemistry to remember. You probably know this, but well, maybe you don't remember it, but you should. But here it is. A milliliter of water is equal to a cubic centimeter. They're the same volume measurement. Milliliter, cubic centimeter, same thing. So over here, we did the zinc. We had 54.0, 63.8, got a difference of 9.8. That is my volume, or the water displaced, when putting the zinc down in there. So I have the data here. It's a mess, so we want it organized. So I have in the lab handout for you, put an organized data table. All right, here's an organized data table for you. Now on this data table, you're going to see where there's some X's, a couple of X's here. That means you don't need that. So for example, I put here graduated cylinder. You want the graduated cylinder mass. And we did that. We took the graduated cylinder mass. This first part is for the water. The second part is for the liquid, which is the mineral oil. And then we have solid 1 and solid 2. So we used zinc and lead. So up here, this is for the water. The graduated cylinder, you need the mass for it. You don't need the volume of a graduated cylinder. Okay, and you don't need to know the density of a graduated cylinder, but you need to know the volume of the water used. So here we've got the graduated cylinder. Okay, graduated cylinder. Boop. Mass 26.511. We'll go right here. 26.511. Write that down. And then the graduated cylinder and the water. Boop. 33.525. Write that down. 33.525 goes here. Then with the water, the mass is going to be the difference between those two. So, oh, my finger's in the way. So the difference between these two masses, graduated cylinder without water, graduated cylinder with water, subtract them, take the difference, put that in this spot here for the mass of water. Now, then you can get the volume of the water by subtracting those two. The mass of the water is going to be the difference in the masses, but we have the volume of the water, the volume of the water by just taking this number right here, volume of the water, 6.9. So water, volume, 6.9. See, there's two X's for the graduated cylinder volume and cylinder and water volume. You don't want those. You want the volume of the water. That's why I have an open spot here. So put that volume of that water here. And then over here, the density, you need the density not of the cylinder, not of the cylinder of water, but the cylinder, but you need the density of the water. So calculate density is mass over volume. Put your answer here, right there, boom. Now you're also, while you're doing this, while you're doing these subtractions to get volume, the subtractions to get mass, and divide mass by volume, and you put that in the data table, you're doing the calculations for the lab. All but one. I'll explain that in just a second. So you're doing that. So fill this data table in. And let's take a look at one of the solids. Down here, we had the solid, the water. You don't need the mass of the water when doing water displacement. Okay, that's the mass in the big graduated cylinder. You don't need that. And what else we got here? The water and the solid number 1, when we added the solid into the cylinder, you don't need the mass of that. But what we do need is the mass of that solid, which we have. We have the mass of the solid, and there's zinc's mass. We got that right from the beginning of the lab, so put that into the table. You do need the volume of the water that you started with. So the volume of the water you volume of the water you started with, we have that. Okay, water before 54. Then put the water after. 63.8. And then you're going to subtract those two. You're going to have our cell number 2. You'll subtract those two and get that water displacement volume for the, oops, I'm at the second one here. This is hard to do, you know. This is easy. You think this is easy? Coordinating and watching this now? Oh my God, you must be getting seasick out there. Here, I was doing the zinc, so it was the first metal. This is for the lead. So go ahead and put the difference between those two volumes here. Again, you don't need the density of the graduated cylinder. You want the density of the zinc, and you're going to calculate that by taking this mass and dividing it by this volume. This lab is not so much about density. It's not. I mean, density, you probably did density stuff in middle school, for crying out loud. So we're not doing this lab for density specifically. We're doing it for measurement in significant figures. Really, for you, it's all about significant figures. So when you do the math on these, when you subtract to get volumes or masses, and when you divide mass by volume to get density, make sure you're using the correct amount of significant digits. So that you have to follow the rules for significant digits. So make sure that you are using the correct amount. Don't just give me the long calculator answer. And don't just round things off haphazardly. Make sure, I'll go back here, make sure that you know how to use significant figures and record your answers with the correct amount. All right? That's what this lab is really all about, Charlie Brown. Okay, one more thing. If we go back here to the questions, it's going to ask you here, once you've completed your measurements, use your chemistry book, or you just Google it, or the data table, or the periodic table I gave you with all kinds of information on it. That first one has densities. Determine the unknown metal's true density. So find out the metal, the zinc and the lead, find out what their true densities are. We're using grams per cubic centimeter or grams per milliliter, so find out what that is, because in this question here, number 1, calculate the percent error of the unknown liquid and the two metals. Well, the unknown liquid you now know is mineral oil, and use significant figures to show the setup for your calculations. So you're going to do a percent error. And that percent error, you might say, well, what's the equation for percent error? Well, some of you astute students will have noticed that I already put the equation down for you on the front. You've got your equations and the background information with the density equation. So the experimental value is what you get. The theoretical, sometimes called the true value, is what you're going to look up and find. So find what the true value is for zinc. Find what the true value is for lead. Put them into that equation. Now, this is an absolute value equation, so you do not use negative numbers. So you're not going to get a negative percent. Whatever you get for the answer, if it comes out to be negative, because you subtract numbers sometimes and they come out to be negative when doing these, just ignore it. It's an absolute value. So get your percent error, and hopefully my measurements weren't too far off. But, I mean, we'll get something under 10%. We're usually trying, usually, I won't say always, you're usually trying to get under 10% errors when we do labs. Some labs are really hard to get accurate values. This lab, we should be able to get under 10%. Hopefully I did. Now, if we didn't, there's reasons. Right there, question 2. What are at least 2 likely sources of error? Now, I will not help you on questions. I will help you on calculations. If you have questions on calculations, I will help you. If you have questions on these questions, I won't help you. Now, the truth is that question number 1 is a calculation. I really should have put that into a calculation section. So, if you have any questions about how to calculate the percent error, then I'll help you on that. Now, the sources of error, there are reasons why there's going to be lab errors. And a lot of times students want to say human error. That's not a lab error. A human is not a lab. A human is not a lab. So you have to come up with lab errors. So that means errors associated with the design of the experiment, materials used. Those could cause some error. I will give you a hint on this since it's your first lab. If you look at this metal, it has a hook on it. And that hook does not look like it's made out of zinc, does it? And okay. And the lead, which is sitting at the bottom of this bad Larry right here, also has a relatively large hook on it compared to the size of the metal itself. What do you think? I doubt that hook is made out of lead, and I doubt this is made out of zinc. That looks like it's made out of steel with different material. Lab errors, huh? Okay, well, maybe that's one. I don't know. Okay, now I also was getting the density of water, and you might have noticed I did not go to a distilled water tub. I did not go to a distilled water distributor. I just used tap water. I wonder, could that make a difference? All right, okay, all right. Then go ahead and answer those questions. Now, two likely sources of error. I've actually kind of given them away in this lab. I won't do that again, though. I would have gotten away with it, too, if it wasn't you meddling kids. All right, and then answer the other questions. So your lab report will consist of filling that data table in. The data table in. Boop, boop. Show your calculations. You can do that off to the side if you want, how you got the density. You can go ahead and do that. I'll see how you got the volumes and mass differences. They'll be right here. It's just a subtraction, how you got your volumes and mass differences. I'll see that. But over here on the side, show your density calculation. You can do that right on the sheet of paper. And then your percent error, errors. Maybe on this sheet here, you want to write your answers. You can go ahead and do it right here. If you want to save some space, save trees, people, save trees. Then go ahead and do it right down here. And then show those calculations for your percent errors. Now you're going to have 4 of them. 4, because there were 4 densities. So show 4 density calculation percent errors. And go ahead and answer the remaining questions best you can. Google stuff, look it up. All right, Google it, look it up, do it. And that is a very quick lab. Essentially, it was a lab for significant figures and using measurement in science. All right, that's lab 1. Short and sweet. Talk to you later.